Hello, year 8. This is Mr. Radmull. This is the space topic and it is lesson 9. And we are going to be talking about the sun, our star, what our sun is up to at the moment, how it got here and where it's going to, and also what things are made in stars as well, and why are we made of stardust, which is the driving question. So can you write down the driving question, please? And your starter question is, which of these statements about our sun is not true? Pause the video. Okay, so it is in fact our sun will not actually shine forever. That is false. Our sun will shine for a very long time, but eventually it will stop shining. Let's talk more about that. So to begin with, let's talk about how our sun and other stars are born. So stars start as a cloud of gas. So a gas mostly made of hydrogen, and this gas starts contracting, getting smaller and squeezing together, and eventually this cloud of gas becomes what's called a main sequence star. And it starts making its own light energy and thermal energy. It starts shining. And this is where our local star, the sun, is at the moment. It's a main sequence star. Now, when the sun starts to run out of energy, more about that later, which is still going to be a very long time from now, it is going to get bigger and it is going to become a red giant. So in actual fact, you can see here, our sun, when it stops becoming a main sequence star, it will get bigger and it will actually engulf Mercury and Venus. Mercury and Venus will disappear, but we will still be just outside of its reach. So the sun will expand to become a red giant. It will then shed off a load of gas, which will become what's called a planetary nebula. So there's our sun in the middle. And then our sun will get smaller again and become something called a white dwarf. And it will burn very brightly, not for very long, and then it will run out of energy and stop shining. So there is our sun now. There is the life cycle of our sun. It's a cloud of gas, then it's a main sequence star, then a red giant, gives off a planetary nebula, and shrinks and becomes a white dwarf. Now, don't panic about the red giant bit. Our sun will be a main sequence star for, we're talking hundreds of millions of years from now, still going. So we're talking about way into the future. So these main stages of the life of our local star, the sun. Let's just get a grip of the order of it. So which of these, pause the video, which of these correctly shows the main stages of the life cycle of our sun, our local star? Pause the video. Okay, so it is in fact D. Our sun started as a cloud of gas, then it became a main sequence star, which is what it is at the moment. Then it will become a red giant, then it will become a white dwarf. So next up, let's talk about our sun and how our sun makes light and thermal energy. What's actually going on inside it? So firstly, let me remind you of a few keywords from chemistry. So everything is made of small particles called atoms, and these atoms come in different types called elements. So for example, gold is just made of gold atoms. Gold is an element. And there's gold there, look, on the periodic table of elements, which is a list of all the different types of atoms. So another example, copper. Copper is only made of copper atoms. Copper is an element. It's a type of atom. There it is there, look, on the periodic table of elements, copper. Now, our sun is mostly made of hydrogen and helium. And we're going to talk about what these hydrogen and helium atoms do to make our sun shine. So inside of our sun, what powers our sun and what gives it light and thermal energy is this process called fusion. Fusion is how our sun makes energy. And it works by this. Small atoms smash into each other at very high speeds, and they make larger atoms. And when they make a larger atom, they also give off light and thermal energy, making the star shine and making the star hot. So this process is called fusion. Now, in our sun, hydrogen atoms are colliding together to make helium atoms, fusing together to make helium atoms. That's the main way in which our sun makes its energy. Now, the detail of this is actually a bit more complicated, so I'm just going to mention it, but it's not part of the writing task today. It's actually the nuclei of the atoms that are smashing together. It's actually two different types of hydrogen atoms that are fusing together to make the helium, and also a neutron is produced as well. So we're going to just stick to ideas of atoms, but in actual fact, as you will find out in GCSE, details are a bit more complicated than that. So firstly, atoms and elements. Let's just quickly review a few of those ideas. Pause the video and tell me which of these statements is the porky pie, which is East London slang for lie. Pause the video. Okay, it is in fact copper pipes are made of copper atoms, because copper is an element. It's only made of one type of atom, copper atoms. Right, next then, this idea of fusion. So again, have a look at these statements, pause the video, and which is the porky pie? Okay, it is in fact that in the sun, hydrogen atoms fuse together to make helium atoms, the next biggest atom on the periodic table. So a star does make energy through fusion. Fusion is when smaller atoms collide together to make larger atoms. This makes light and thermal energy. It's also called fusion and is also made in fusion. And in the sun, hydrogen atoms fuse together to make helium atoms. So let's just talk specifics about our sun and what's happening inside of our sun. There it is there, look. So as we've just talked about, the sun then is mainly made of hydrogen. And the hydrogen is like the fuel, like a petrol powers a car. Hydrogen is like the fuel that powers the sun. So as you can see, there's still loads of hydrogen in the sun, and there's a small amount of helium, because that's the helium that's been made from the fusion of hydrogen in the process of fusion, making energy. Okay. You can also see, look, there are also larger atoms present in the sun, although there are not very many. And these larger atoms have also been made by fusion. They've been made by fusion of the helium atoms, which fuse together to make even larger atoms. And this process just goes on and on and on. As you can see, not a lot of these larger atoms have been made in the sun, because the sun hasn't got an awful lot of energy to make the much needed to make much larger atoms smash together at appropriate energies. But you can see there, look, so mainly hydrogen and helium, but also some larger atoms present in the sun as well. Now, in terms of atoms that are really, really large, larger than iron, say, these can't be made in the sun. The sun has not got enough energy for that. So to understand how these atoms have been made, these much larger ones, we have to think about stars that are much, much larger than our sun. So supermassive stars. Now, supermassive stars, which our sun is not, our sun is a relatively small star, but supermassive stars will do something a little bit different when it comes to becoming a red giant, because they will eventually go supernova. So a very large star, which is not our sun, will eventually explode, and this is a supernova. So a supernova is when a very large star all collapses in on itself, lots of energy made in a very short amount of time, and then there's an explosion, and it's the biggest explosion possible in the universe. And the energy involved in the explosion is incredibly large, and it's enough energy to make much larger atoms. It's the only time in the universe when there's enough energy to make these larger atoms than iron. So anytime we come across atoms that are larger than iron, they must have been made in a supernova, in a star exploding. So any atoms, for example, in your body that are larger than iron, the only way that those atoms were originally made was through a supernova, which is why part of you is made of stardust. So bringing these ideas together, pause the video. Where's the porky pie? Okay, so the sun is mainly made of hydrogen and helium atoms. That's right. In the sun, the main fusion reaction is hydrogen fused to make helium. That's true. There are also larger atoms in the sun made from helium atoms fusing together. That's true. However, you can't make any size atom in our sun. You need to have a larger star or a supernova for that to happen. So this idea of a supernova, let's just tackle that. Have a read through which statement is false. Pause the video. Okay, yes, it is in fact only a massive star will go supernova, will explode. So a star like our sun is not big enough for a supernova to happen, which I think actually is a good thing. Be spectacular to witness, obviously, but pretty happy with the sun that we've got. Okay, so only very large stars will go supernova. Our sun does not have enough mass to go supernova, and a supernova is the only natural event in the universe with enough energy to make atoms larger than iron. So let's bring these ideas together, please. So for number one, can you order the stages of the lifetime of our sun? Number two, can you explain how a star makes its own energy through fusion? Sentence starter in red. Number three, explain why the sun is mainly made of hydrogen and helium. And then number four, explain why can some atoms only be made in supernovas. Pause the video. Right, so for describe, you should get all stars start as a cloud of gas. Then they become what's called a main sequence star for a very long time. Then they become a red giant. Apologies, that should say red giant, not red dwarf. And then they become what's called a white dwarf. So here, look, I will just quickly correct that. Apologies, and apologies for the handwriting. It is a red giant, not a red dwarf. There you go. Okay, so next up, how does a star make its own energy? A star makes its own energy by smaller atoms colliding together to make larger atoms. This is called fusion. Fusion also makes light and thermal energy. And explain why the sun is mainly made of hydrogen and helium. In our sun, hydrogen atoms collide together to make helium atoms. This is why the sun is mainly made of hydrogen and some helium. A much smaller number of larger atoms are also made through helium fusion. And why can some atoms only be made in supernovas? Well, the sun only has enough energy to make atoms of a certain mass. A supernova is when a star much larger than our sun explodes. So in the explosion, only then is there enough energy to bring together these larger atoms, fuse together these larger atoms to make atoms larger than iron. Okay, so can we now copy and complete the plenary statement, please? Today I've achieved a describe because I can state the stages of lifetime of our sun. Today I've achieved an explain because I can explain how a star makes its own energy through fusion. Today I've achieved a use because I can explain what the sun is made of. And today I've achieved a combine because I can link in ideas of supernova and energy to explain why only certain atoms can be made in a supernova. Okay, and don't forget is a show my homework quiz for you now to complete, and we will be recording results and sometime in the future communicating those results to parents and guardians. Thank you very much, Year 8. Stay safe, stay happy, and I'm wishing you well.